Tired of dropping your phone or struggling to prop it up? Meet the Pop Sockets phone grip with expanding kickstand in black, your new must-have accessory. Don't miss out. Grab yours today. Click the link in the video description to shop now on Amazon.
Welcome to NASA News Network, where we explore the latest breakthroughs in space and science. Today, we're going to talk about a fascinating discovery that's been making headlines lately. Imagine being able to see inside a black hole, one of the most mysterious cosmic objects out there. Sounds like science fiction, right? But thanks to NASA's Imaging X-ray Polarimetry Explorer, or IXPE for short, scientists have finally shed some light on how X-rays are generated in these extreme environments. IXPE is the only satellite flying today that can make a crucial measurement: polarization of X-ray light. This means it can tell us whether X-rays come from protons or electrons. For years, scientists had two competing theories, but now we have the answer. Joining me to explain this groundbreaking discovery are Stephen Ehlert, project scientist for IXPE at Marshall Space Flight Center, and Ioannis Liadakis, one of the primary authors of the study and astrophysicist at the Institute of Astrophysics, fourth in Greece. So, how did they figure out that electrons are responsible for X-ray production? Well, it all comes down to a process called Compton scattering. When a photon interacts with an electron, it loses or gains energy. IXPE observed this phenomenon in the case of a blazar jet, where electrons move near the speed of light. The team collected data from 7 days of observations, along with ground-based telescopes measuring optical and radio polarization at the same time. What they found was that the X-rays were far less polarized than the optical light. In fact, the X-rays couldn't be more polarized than 7.6%. This is a crucial clue that tells us electrons are interacting with photons via Compton scattering. Stephen Ehlert from IXPE explains it this way: the fact that optical polarization was so much higher than in the X-rays can only be explained by Compton scattering. Now, you might be wondering what's next for blazar research. Well, Stephen and his team plan to find as many of these objects as possible because they change quite a bit with time and are full of surprises. That's all for today's episode of NASA News Network. Thanks for joining us on this journey into the unknown.